All right, let's get started. So I'm assuming you can see my screen. If not, speak up because I can see your chat. So today I wanted to talk about containers and specifically Docker because that's what you always hear about, and how GitLab is involved in that. So if you don't know what a container is, the idea behind containers and in the past VMs and other initiatives that are similar is that you can split up your applications in small scalable parts. And the reason for that is that you want to be able to quickly migrate, do migrations, for instance, you want to be able to quickly scale up, and there's a few other advantages which we'll go over in the coming slides. So you might be familiar with a virtual machine. I hope you are. The idea of a virtual machine is that you have some sort of infrastructure. So it can be a single server, it can be multiple servers. Then there's some sort of system on top of that, often it's called a hypervisor. And on top of that, you run little virtual machines. The name is really correct. And that means that you have an entire operating system. So that can be any flavor of Linux, it can be Windows, for instance. And that's a self-contained operating system, so you can do anything you want there. For instance, if you want to run GitLab, you can make a virtual machine. You can use one of the OSs that we have for GitLab, and you can just run entire GitLab inside of that. This is a really great model, and this makes it very easy to scale because you can simply say, okay, I have this infrastructure, but for this application, I only need a tiny bit of the power of this infrastructure. I only need a single CPU core. I only need a little bit of memory, and that allows you to run many different things on maybe only a handful of servers, or even on a single server, you can run many different operating systems. So this is a really powerful idea. And this is something we use every single day, and it's used by every big corporation in the world. Now, a few years ago, people started thinking about how can we improve upon this? How can we make this, what we have right here, better? And it's hard to think of how to do this better because this is already such a powerful model. But what they did is they designed containers. And the idea of a container is that you have a similar sort of setup, but rather than having the entire stack of the operating system below each little virtual machine, we're just going to share that as well. So, and what we have left is only the differences. So we have these little containers, just like the virtual machines, but they don't need to have the whole operating system anymore. Rather, they only have what is unique to them and nothing else. And this makes that you can make much lighter, much smaller packages, containers, and run your applications in that. And it also has the advantage that you don't need to provision the entire stack that is below it. So where you had in a virtual machine, you have the whole guest operating system that you have to provision, that you have to make sure it's all set up correctly. In a container, you make certain assumptions about what is already there, and you have shared resources that are already there, so you don't need it anymore. So you only have to think about, okay, for this application, maybe I need Ruby, a programming language, then I need to make sure that in this container I have the dependencies for that. And I don't have to think about anything else. And the nice thing about this is that you can define this in a single text file. So you're all familiar with the advantages of having things in a simple text file because you can version them, you can look at them, you can easily edit them, you can put them in GitLab. So to build a container, and the most popular file format is a Docker file, you make a Docker file, and in that you define exactly what this container has to do. So previously we had VMs that were really complex, you had a whole operating system that you had to configure, and then you could replicate that, but it was a bit of a pain. And now with a container, all you need to do is you have to create a single text file, a Docker file. And this is what it looks like. So in the top, you say, I'm going to define this Docker file from maybe another certain container or certain type. And then I'm just going to write down here what needs to be happened. So we don't need to install operating system. We already have all those things set up. We only have to define here, okay, in this case, I took one that configures Ruby. Okay, let's only set up the dependencies for Ruby, and that's all we need. And what we do then is we simply say, if we use Docker, there's alternatives, but if we use Docker, we say Docker build, and we build a little image, a little container image, that then we can use easily, and we can create a single one, can create 100, and it will only be a matter of seconds to create those. Before I go into much deeper, are there any questions about this? All right, so if you have any questions, just speak up. All right, here's someone. Yeah, go ahead.
I constantly hear the term image. You said image. Can you just explain what you mean by image?
Sure. So when we're talking about image, we're just talking about a file that's a certain snapshot, as it is. That's why we call it an image. It's if we're talking, for instance, about a virtual machine image, that if you have a virtual machine, it is of course a running operating system, but we want to commit a certain state of that operation of that VM to a single file, so that I can take that and replicate that. That is what we call an image. So it's basically a single file that we've created from a VM, from a container, that we can replicate, we can put somewhere, we can store it on a hard drive, we can send it somewhere, and then we have the exact same thing somewhere else. Does that clear things up?
Thanks a lot.
Anything else? All right. So just to recap, all I did so far is I said, okay, I want to have this certain type of container that has to have certain dependencies. So I made a Docker file. I wrote it here. This is literally all that is necessary. This is really what it is. And I can put this in version control. And then what I did is I told Docker, okay, build a container for me from this file. And it's a single command, which is docker build. And what Docker does is it makes this image. And that image we can now use to do other things. So for instance, if we want to use GitLab, we can say, okay, if we want to have GitLab, we want to build it on top of this image that I made, and we can just use that image. So to use that image, we have to store it somewhere in like a central place. And that's a thing. So what you can do is you can store your Docker images in a registry. And this allows you to, from any other place, reference this image with a single line, and I say, I want to use this. So let's say I have an application that uses Ruby. If I want to make use of the image that we just created, if I upload it to a registry, I can just reference that, and I don't even have to think about it. So in the past, I had to define my VMs, and I have to make sure that's all in the right place. But with Docker, all I need to say is that, oh, I made this Docker image somewhere. This is what it's called. Please use that when running my tests or when deploying my application. And this is a really interesting concept. And we think it's so interesting that we are working on our own container registry, so that rather than you create a container and you send it, for instance, to the registry of Docker, the company, or to a proprietary one that you pay a lot of money for, you can just have it in GitLab and have it be available right there and use it for your own tests. And before you're asking questions about this, I'm going to show you how you can actually use that, because as I said, it's just a single line. So you know GitLab CI, and you know that GitLab CI, you define your tests, for instance, in a .gitlab CI YAML file. And this is one that you can see right here. So what you see here is that there's a test 2.1, and that runs the test of this specific repository. But what you see on top is that image and then a line, Ruby 2.1. So actually, this is a reference to one of these Docker images that is in a registry available. And what this means is that when it runs test 2.1, it will use the image for Ruby 2.1 and then do the script, do the commands that you see below it. And the nice thing is that if we want to make sure that whatever we are building also runs in Ruby 2.2, you see right below that the only difference, the only thing we had to change was change the name of the image and say, now I want to use Ruby 2.2. And because containers are so small and so lightweight and so easily provisioned, we don't have to worry that this will take a very long time. Now, in fact, this is very fast. This is almost instantly. And we can actually run these at the same time because these will be separate containers. And once we're done with them, we just throw the containers away. This was a lot to take in. Are there any questions? No, I'm glad to see that you're all experts on Docker already. Again, if you have any other questions, to speak up. We're burning through this. Now,
I have a question.
Yeah, go ahead.
Sorry if this sounds bad. I saw that somebody ask on Twitter or say something on Twitter that, you know, by allowing GitLab pages to run basically anything on our server, that, you know, is open to security problems. And then I think someone said something like, well, it's all, I forget what they said. It's all like, you know, is it because we're running everything in Docker or containers that it's secure?
Yeah, that's a nice thing to talk about. So what we do is that GitLab CI, and I'll get back to this at the end, but GitLab CI can use Docker and containers instead of using just plain old VMs. So for GitLab pages, what we do is we run everything in a little Docker container. And the idea is that the Docker container is self-contained. So everything you can run inside of that, you can just go mad. You can run whatever you want inside of that. Because once we're done with it, we're just going to throw it away anyway. You're not able to go outside of the container. You're not able to go to other containers if we are provisioning it like that. So yeah, that's exactly what it is. It's a fully self-contained unit, and you can do whatever you want in there, because then afterwards you're just throwing it away anyway. It's not going to be reused. You not have any data left there. It's just we make this container just for this one job, and then we're throwing it away again. And this, we could only do this with Docker because it's the only technology that is fast enough to quickly create this container, spin it up really quickly, and allows us to then destroy it on demand. Does it make sense?
Yeah, it does. I went through the Docker tutorial, so some of it's very familiar, but yeah, it's basically what you're saying is once the Docker machine is used to run the scripts that build the static sites, in this example, those static files, those HTML files just get put into the repository, and then the Docker machine is destroyed. It's not needed anymore.
Yeah, that's correct. It's actually not the Docker machine. It's the container that gets destroyed. So what happens is that we build our build artifacts. So what happens is that you have this process that runs within the Docker container, and that process has a certain output, and that output is what we call the build artifact. And in the case of pages, that build artifact is just a number of HTML files that we put in a specific place. So that is exactly what happens. So you push a commit, that commit triggers CI. CI says, okay, let me have a look at the GitLab CI file, at the YAML file, and it's what we're looking at now. And there it sees that we're using an image and that we want to use Docker. So it says, okay, I'm going to grab this image, I'm going to build this container, and then I'm going to run the commands that are below it, which you see here at below script. So it's only one command, bundle exec spec. So it's going to run that. That has a certain output, and in the case of pages, that output is actually putting stuff out of the container and putting it in a certain place. And then once it's done with the whole process, GitLab CI says, okay, this is done. This container is completely done with whatever it needed to do. Now we're going to throw it away again. And whenever someone else needs a container, we recreate it.
That's helpful. Thanks.
All right. So we have the containers. They're easily defined, and we put them in a registry so that we can then reference them from any other place. And we are working on a registry so that you don't have to go to external services. There are services, of course. This is one of the ways that, for instance, Docker wants to make money, and there's open source tools for that, also from Docker, by the way. But we're building one in GitLab to make this even easier to do. Now, if you have a big application, you don't just want to put it in a single container. The idea of containers is that they are small and lightweight. And having the power to quickly spin up, to quickly create a bunch of containers, allows us to do much more cool things. So you might be aware that if you have a highly available application, that it can often consist of multiple VMs, right? So you have servers, someone goes to your website, and they get put in one of the servers so that we can distribute loads and we can handle a lot of people, all the millions of people using GitLab. So this is, of course, very easy to do with containers in the sense that it's very easy to create many small instances. And this is something that we do. And this is something that one of the main uses of containers, you want to be able to split up different parts of your application in different containers and then scale those up by just creating more and more containers. Now, To do this, you need a scheduler. So a scheduler, a container scheduler, is something that allows you to easily manage all these containers. So whether you're managing 10 or managing 1,000, container scheduler is the one that will create them, allow you to connect some of them, and allow you to put them down again. Now there are several different schedulers. There's Docker Swarm, that is the nice image that I put there. There's Mesosphere, and what I think is one of the biggest right now at the moment is Kubernetes. This is made by Google. This is what most people seem to be using, even though the other ones get quite some press as well. It's Kubernetes that most people lean towards, and it's used internally at Google, and it's one of their biggest projects. So what we did with GitLab is we played into this. We knew that GitLab was, that Docker was becoming really big. We know that containers, it's a really powerful concept, and it's something that we'll see growing more and more over the coming years. So what we did with GitLab Deploy, which is already out with the last release, is that you can deploy directly to Kubernetes. So we use Redspread, and I'm sure you read the release post and still remember this, that all you have to do is you have to define, oh, what is my container, where do I want to use it, and then you need only a single command and point towards your Kubernetes cluster, so where your Kubernetes lives, that can, from that environment, create your containers, and you can deploy your application like that. Any questions about this before we move on to the last part? All right. So this is a really nice technology, and using containers and Docker files. And oh, my browser crashed.
Hold, please. His browser crashed. I can see your screen. Can everyone see your screen?
Yeah.
Weird.
And I should be back now. Am I back?
Yep.
Great. And you can see my screen, right? Yeah, I can see it. All right. So I was summarizing, so you didn't miss anything, and Ashley and Myron can confirm. Kubernetes is a really powerful technology, and so it allows you to easily create clusters of containers. So the idea behind this is that you can easily scale up, and you can easily make sure that everything runs as it should. For instance, if you want to do a migration, you just run it on part of the container, see if it works, and then you're going to put it on the rest. So these kind of things, there's a lot of things you can do with containers. It's a really powerful technology, and it builds, of course, on what we are already doing with VMs, but now with the ability to do it smaller, easier, and much, much faster. So are there any questions about this that I might have missed while I was offline? All right. So this is really nice, and we think that these container technologies, they are the future. But the future is not something we should be waiting on, especially if we are in the business of creating software. So what we decided to do is we thought about how can we leverage this technology for ourselves? How can we, in a smart way, make sure that everyone can use this kind of technology today? So what we did is we built GitLab Runner Autoscale. And the idea behind this is that, well, we know that we have these containers that are small and easily provisionable, and we can easily create many of them. And, well, we have CI that runs build. So what we did is that you could already use Docker in your CI builds. So you could, like I showed you before. And what we did with Autoscale is that whenever you need it, we automatically create new Docker containers to run your tests. So it works a little bit like a scheduler, but it's not really a scheduler because schedulers do many more things. They're very complex. And a GitLab Runner Autoscale is just simply one thing. That is, when many CI builds are waiting. So when you push a new commit in GitLab and you have CI set up, you see that it's pending first, right? Maybe if you create a new merge request. And then after it's pending, it starts to run. And when it's run, it's done, it's completed, and it either is passed or it failed. So the moment that it's pending, it's actually waiting for some machine that you assign to it to become available. For instance, I have 5 VMs, and if they're already running other builds, then my build that is pending, it just has to wait for one of them to become available. And so what GitLab Runner Autoscale does is that whenever there's a pending build, it just creates a new container. And then when it's done, it just breaks it down with the power of GitLab Runner inside of it. So that means that, and you can see this graph, here you can actually see the Docker containers that are being used at any moment. If there's a high demand, and for us that's like in the afternoon European time, that is when the US is waking up, and most of our developers are working and pushing, we are needing a lot of CI builds. So GitLab Runner Autoscale, what it does, it just creates a whole bunch of containers for all the tests so that no builds have to wait for this. And once demand dies down, when we all go to bed at night, or for instance in the weekend, you can really clearly see that here at the beginning of the weeks. Well, there's no demand for machines, so we're just not going to use them. And the advantage of this is that we just don't use all the virtual machines, or for instance DigitalOcean, which cost money per second that we run. So GitLab Runner Autoscale automatically scales up the amount of containers that we need for CI, and it scales them down when we don't need them. And that saves a lot of money. So this is a really powerful concept, and I think it's a really cool feature. Any questions about this?
Yeah, Chad here. We run this on .com, correct? Like this is the only thing it's running on. Okay.
Yeah. So we just enabled this for Go.com, and we work together with DigitalOcean to make sure we can actually provide it to everyone. And we can set an arbitrary limit. Like here, you see that the limit is set to 127 containers. We could scale that up. So if there's more demand, that we can reach that ceiling. And this is really nice, so that we can provide, in our case, we can provide to a huge community of people all the whole CI thing, which normally is very expensive to run, but we're only paying for the actual usage. So whenever some people are not using it, we don't have to pay for all these machines to be idling, which is what in the past would be the problem with these kind of things, and many other CI companies face as a problem. So the very last thing I wanted to briefly mention before you bring me all your saved questions that you all clearly must have is that you can also run GitLab with Docker. So I've been talking about running your tests, and we use it for GitLab pages, and we use it for GitLab Autoscale. The whole idea is that if you have any kind of application, you can deploy that with Docker. Now, obviously, GitLab was developed before Docker became a thing, before containers were a thing. So this is not what we used to do from the outset. We're not always thinking, oh, we should build it on containers. But of course, once Docker became popular, the community actually started a GitLab Docker, meaning that you can just deploy GitLab with Docker. So if you have a Docker cluster somewhere like Kubernetes, all you have to do is you have to reference this Docker image that contains GitLab and all its dependencies, and you can deploy it the same way as you deploy anything else with Docker. Now, the community did this. We thought we should do it ourselves as well. So there's an official GitLab Docker image, and right now it's just a single container. So as I told you, you can have multiple containers. From the box, it's just a single container right now, but of course in the future we're going to make it such that you can deploy GitLab Docker with a single container, or you can split it up and easily have a very highly available setup where, for instance, you run your database in one Docker container, you have your app server in many other containers, etc., etc. And that was everything I had to tell about Docker for today. Are there any questions about any of the previous or anything else? We have a lot of time. I'm really comfortable here in Ashley's office.
Yeah, I have a question.
Go ahead.
This is Ryan. I've been getting some emails just from leads coming in that ask about Docker to AWS.
Yeah.
I'm not exactly sure what that means or how that plays into GitLab. Can you talk a little bit about that?
Yeah, I mean, please send them through, because there's many different things. So AWS, of course, has many different services for containers for Dockers. So they have their own scheduler, like Kubernetes, like Docker Swarm. There is an AWS container scheduler, I think, or container service. They have their own container stuff that is not necessarily Docker. So it depends a little bit on what you want. But basically, any of the things that we've previously been talking about, whether it's a registry or whether it's an environment like a scheduler where you run your containers, AWS has services for all of those things. So in many cases in GitLab, because the way we build CI, that you can just do anything you want, we can connect with these kind of services, and we can do a lot of it. If you want to run GitLab in Docker on the AWS, that's all possible. But for specific use cases, just send the question forth, or make an issue or something, so that we can actually follow up what they want exactly. This is really interesting for us, and this is clearly the future. It's the future for it's going to be in 5 years much more prevalent than it is now, but everyone is playing with this right now. So it's very important that we spend a lot of time thinking about how we can play into this and how we can make sure that everything we do works well with these kind of systems. So whether it is just Docker, whether it's Kubernetes or AWS, in the end, we want to be able to support everything.
Okay, great. Thank you.
Any other questions? All right, if there's no other questions, that's it for today. If you still have a question later on, you can always ping me on Slack or just send me an email or something. Thank you all for listening.